Turbulence with mixing. There are times when the atmosphere undergoes vertical mixing due to various causes, but there is no mixing condensation level. That is, saturation does not occur and cloud does not form. This vertical mixing can result in turbulence, that is, strong vertical motions and stronger wind gusts experienced near the surface. The two types are thermal turbulence and mechanical turbulence. In the case of thermal turbulence, surface heating can drive strong up motion and the exchange of parcels of air in that turbulently or thermally mixed turbulent region, or radiative cooling at the top of the layer, also destabilizing the lapse rate or the temperature profile and producing thermal mixing. Mechanical turbulence occurs when there are strong winds aloft in the atmosphere, and so parcels are exchanged between the top and the bottom of that mixed layer. This is enhanced by things like surface friction and topography, so mountain ranges and large buildings and so on. So mechanical turbulence happens when there's mixing without saturation due to strong winds. A schematic is shown here on the right where there is 30 knots of wind aloft and 15 near the surface, and so parcels of air are mixed through that region. Some parcels that are moving horizontally with 30 knots will be brought down to the surface, and so wind gusts of 30 knots on top of the 15 knot mean will be experienced. Gradient level is the level of 3,000 feet above surface level. And if you have 25 to 30 knots of wind at gradient level, strong mechanical mixing will occur. This is of course enhanced in the lee of surface features like the ranges because you get downslope winds, that is, winds flowing down the particular feature and enhancing the gust that you see at the surface. Aviation forecasts must mention turbulence when it's considered to be significant. If you have 25 to 30 knots at gradient level, then you are likely to experience moderate turbulence, and if it's 35 knots or larger, severe turbulence should be forecast. An example TAF forecast is shown in the box, where the wind conditions are 270 at 15, gusting to 30 knots, and moderate turbulence below 5,000 feet has been forecast. And the value of 5,000 feet is the top of the height of an aviation forecast, a terminal aerodrome forecast. So what do you think about this profile? Would you expect stratocumulus? Would you expect turbulence to be forecast? Stop the video and have a think. Well, what do you think? Other than a small inversion near the surface, the temperature profile below about 4,500 feet is a dry adiabat, and the dew point temperature profile is roughly a mean mixing ratio isopleth. And so that layer's already been mixed, and the result of that has been not to produce a mixing condensation level. So there shouldn't be any cloud associated with this. If you look at the wind profile on the right, you can see there's up to what looks like 40 knots at about 3,000 to 4,000 feet. And so it's likely that this is going to be associated with some moderate, potentially severe turbulence low down.